So now that we're pretty comfortable working with quadratics, finding their vertices, and graphing them, we want to talk about some of the applications of quadratics. Quadratics are really nice because their applications can be done without the use of calculus. So there are a lot of applications to non-quadratics that you have to have calculus for, but you can do all of the applications for quadratics with just algebra. So that's why we focus so heavily on them. So we're going to take a look here, and it says that the Montana Dude Ranchers Association, there you go, has 400 feet of fencing to enclose a rectangular corral. But to save money and fencing, the association intends to use the bank of a river as one boundary of the corral, as seen in some figure that we don't have on this slide. And we should find the dimensions that will enclose the largest area. Well, let's talk it through again, okay? We're being asked to find what? The dimensions. We want to find the dimensions of the corral that will enclose the largest area. So we need to get a good visualization on what's going on there. So first off, we have a river. There's my river. Along that river, I'm going to build a pen. I'm going to build it rectangularly, but I'm only going to have to build 3 sides because I'm going to use the river as a boundary and hope that my cows and sheep aren't stupid enough to drown, right? Right. So the idea is I need to know what should this width and this length be to have the largest area possible. But I can only use how many total feet of fencing? 400. Great. Y'all ready to try it? Okay. So first off, we need to label these. Let's let one of these sides be x. Is this okay? Let that be x. Okay, to avoid a 2-variable situation here, I would like that third side to be a function of x. Like I want to know, with respect to x, how much is left. How much did I have to start with? 400. I had a total of 400 to start with. How much have I used? 2x. So what's left? My total minus what I've already used. That's the hard part, is getting that picture drawn there. That's where people get into trouble. You pick something, you let it be your x. Usually the one you have 2 of. That's usually what I do. And then the remaining sides have to be the total minus what you've already used. So this is total minus what we've already used. Is everybody good with that? Okay. Once you have that drawn, you can come back through and think about what you're trying to find. I'm trying to find the dimensions that will give me the largest area. That's called optimization. That means you want to maximize or minimize something that will be in your best interest. So I want to maximize the area. I'm going to write an equation that will find the area of that corral. So what is the area of that corral? It's just the length times the width. So it's x times 400 minus 2x. So we have x times 400 minus 2x. Now I'm going to distribute all that out so that it looks like a quadratic equation. So instead of y equals, I have the area equals 400x minus 2x squared. If I rearrange it, it's really negative 2x squared plus 400x plus an understood 0, so that you can see it in quadratic form, where this is little a, this is little b, and that's little c. So take a minute. I'm going to pause and let you see if you understand that and if you have any questions still about that. So once we have it written out in general form of a quadratic equation, we need to know what point are we interested in here. What point are we interested in?
X.
Does anybody know? Okay, we are looking for the point that will provide us the largest area. Another way to say largest is maximum. With a quadratic, the word maximum should make you immediately think about what point? The vertex. And that's the point you are always going to be interested in here. You're going to be interested in the vertex. Anytime you're trying to maximize or minimize something, you want to find the vertex. So that's where you go from here. You say the x value of the vertex is equal to opposite of b, over 2 times a, which in this case is 100. That's the x value I care about. That is the single x value for that entire parabola that will provide you maximum area and still only use 400 feet of fencing. That's part of your answer. I want to know what x is. So I know that x has to be 100 what? Feet. So there's one part of the question. That's what I need x to be. That's my width or my length, whichever you want to call it. But I want to find the dimensions, which means I want the length and the width. So how do I find this? Plug it back in here, right? So what is 400 minus 2x?
200.
Yes, it's 200 feet. Those are called your dimensions. And that is all this problem asked you to do. The problem didn't ask you to find the y value of the vertex. It only asked you to find the dimensions, which is the x value of the vertex. And then you use that x value to come down along the bottom here and find the remaining dimension.
You don't find the y vertex, you just plug it back in.
Not for this problem. You didn't have to find the y of the vertex for this problem. However, if I added something onto this problem, and now I asked you, what is the maximum area? Now I know that 100 feet along here, and here, and 200 feet along here is what's going to give me the maximum area. What is the maximum area? Anybody? 20,000 what? Square feet, right? How'd you find that? There are 2 ways you can find it. Yeah, you can look up here, and you can just say we know that length times width is area, right? So that's 20,000 square feet. Or that happens to be the y value of the vertex. You could come back over here, like you were saying, Taylor, and you could plug in 100 for x, and you can plug it in anywhere, actually. You can plug it into either one of these. Plug 100 in for x, and that would tell you the area. So that's actually acting as your y value of your vertex. The area of the vertex is 20,000 square feet. So a lot of people struggle with this because they don't know what they're being asked to find. A lot of times they can get it set up and they can find the vertex, but they have to, you have to read very carefully to see what were you asking for. I was asking for the 100 and the 200, but I could just as easily have asked what will be the maximum area that he could build.
So basically you just have to be conscious, are you looking for dimensions or area?
Pretty much, yeah. And because that's going to determine whether you use the x values or the y values. And occasionally you're being asked for both. So you just have to read it really carefully. For this example, we're being asked to find a minimum cost. Let's read through it together. We know that a company makes and sells webcams, and it has found that the total weekly cost that they have for producing X number of webcams is given by the function C of x equals 0.5x squared minus 210x plus 26,250. They know that. Unlike the previous example, in this example, you are given the quadratic function that models the situation you are trying to maximize or minimize. We're asking you to find what? Let's read it very, very carefully. You're being asked to find the production level, right, that will minimize the cost. And you're being asked to find the weekly minimum cost. So be very conscious before you start the problem of what you're being asked to find. Highlight it, underline it, circle it, whatever it takes. So take your function, C of x equals 0.5 x squared minus 210x plus $26,250. And tell me what point on there am I interested in if I'm trying to maximize or minimize anything?
Vertex.
The vertex. So any problem it asks you to maximize or minimize something at this point, the only thing you know how to find max or min of is a vertex. Is a parabola, and it's gonna be the vertex. So even if you're not sure, find the vertex, okay? Maybe you'll get partial credit. If you're really not sure what it's asking, you know it has something to do with the vertex, so start there. So the x value of the vertex is equal to opposite of b over 2 times a, which in this case simply turns out to be 210. 210 what? It's a word problem. Give me some units. What do the x's stand for?
Webcam.
They're webcams. So 210 webcams. That's the x value of the vertex. Would you say that means production level? That's your production level. That's how many you have to produce. 210 webcams answers the question of what production level we should work at to give us minimum cost. I want to know what will cost me the less to make. Okay, that answers the first question. Now you're being asked to actually find the weekly minimum cost. Which variable stands for cost? The C variable, right? So basically that's the Y value. It's acting like the Y value. So if I want to find the Y value or the C value of the vertex, I simply substitute 210 into the original. And see what I get. Could somebody crunch those numbers for me really quick and tell me what cost that produces? 4,200. What are the units there? Dollars. Okay. So that answers the questions of what's the weekly minimum cost. So we answered both questions. That means that I'm going to have to spend a minimum of $4,200 just to run this. And the best way to do that is by producing 210 webcams a week. That will only cost me $4,200. Why would we be interested in minimizing the cost to me? When I minimize my cost, what does that maximize? My profit. Yeah, so if I want to make a good profit, I can figure out what that is by minimizing the cost.